4 seasons. Latitudinal variations in the input of solar energy are due to 2 factors. First, the Earth is a sphere, and the angle at which the sun's rays hit its surface varies from 90 degrees, or vertical, near the equator, to 0 degrees, or horizontal, near the poles. Less energy is received at the poles because the same amount of radiation is spread out over a much larger area at high latitudes, and because at high latitudes the sun's rays must travel through a much greater thickness of atmosphere, where more absorption and reflection occur. The second factor affecting latitudinal variations in heating is the duration of daylight. Because the polar axis of the Earth is tilted at an angle of 23.5 degrees with respect to the ecliptic, we have a progression of seasons where the angle of the sun's rays striking any given point varies over the year. In the Northern Hemisphere winter, no sunlight strikes the area around the North Pole during a full day's rotation of the Earth, because it is in the Earth's shadow. Thus, little or no solar heating occurs in this area at this time. Conversely, at the South Pole, there is continual daylight, but at a very low sun angle during the Northern Hemisphere winter. As the seasons shift, the South Polar region eventually becomes plunged into 24-hour darkness, just as the North Pole had been earlier. Low-latitude regions near the equator, by contrast, undergo little seasonal change in the duration of daylight, whereas intermediate latitudes are subjected to changes intermediate between those of the poles and the equator. Thus, because of seasonality, more annual radiation is received per unit area at lower as compared to higher latitudes.